And you can also download ParaView from paraview.org/download. Okay, so before we talk about ParaView, just a quick word about Kitware. So maybe you know, maybe you don't know, but ParaView and many other open source software is developed by Kitware. Kitware is an international company that developed many open source solutions with more or less 300 employees, and it's been created more than 20 years ago when VTK was created. So I'm a Kitware employee, and we are all engineers, developers, PhDs there. So what is ParaView? So we say ParaView is an application and an architecture for display and analysis of massive scientific datasets. So I will go deeper into this definition, and I will use this definition to show you different aspects of ParaView, especially for people that are really not used to ParaView. So if you never use ParaView, you're very welcome here. That's perfectly fine. If you use ParaView once or twice, you will learn many things. If you're already an advanced ParaView user, maybe you will not learn so many things today, but you will still have some good insight into features maybe you didn't know. Okay, so we say ParaView is an application because you don't have to write any code to analyze your data. Just an application, you double click, it opens, you click in the buttons, and everything happens. It's also an architecture because ParaView is a framework that is designed to be extensible. If you want to create your own, plugins, your own application based on ParaView, if you want to use Python scripting, this is all supported by ParaView. ParaView is of course for display, so you can take any data, of course OpenFOAM data, but if you look at the number of formats we support, it's very high. So you can display this data and you can analyze this data, try to find the most salient information inside your data. And it's for massive scientific data set because it's designed to be scalable on HPC, on supercomputer. Basically, it's designed for exascale. We can say that its strength is its flexibility as you create VTK pipelines. You create VTK pipelines with ParaView. So yeah, an application, you don't need to be a programmer. Basically, if you don't know, ParaView is based on VTK. VTK is a visualization toolkit. It's a framework for visualization. ParaView takes many of the filters from VTK, the filters or data processing algorithm, and they expose it in an interface where you can click on buttons. So this is an application because you have an extensive help. You can do undo, you can do some selections, you can do animations, and you can configure all the layout, and it will stay as a setting. So this is really this applicative side that make it easy to use. So how does the interface of ParaView look like? Basically, you take ParaView, you open ParaView, and you present it with this. On the first open, it may be a bit overwhelming, but still, it's you will find whatever you find in any typical application. On top of here, you have the menu bar where you have all this file, edit, view, and so on. Then you have many toolbars, a bit too much sometimes people say. And then you have all this on the left, pipeline browser and properties panel, and then all the views. So the pipeline browser is one of the main components of ParaView. For example, in the pipeline browser, you will be able to control exactly how ParaView will behave, and you will basically, it shows you a view into the VTK pipelines. Here, in this specific example, we have a file which is open, and we have some filter applied on it. We have another filter which is connected to something else. It's basically a representation of this graph here. Yes. And in the pipeline browser, there is this very important concept of active source. So the active source is basically the one thing at a time that you are controlling, you're currently controlling. If you click on the pipeline browser on any source, you will make it active. And this is something to keep in mind because when you change the active source, it changes a lot of things in the application. Then you have the view area. As I said, when you click somewhere in the backend browser, you will see that here the properties panel will change. So if I click on glyph, it will change, show me the properties of the glyph. If I click on plot selection over time, it will change and show me the properties of the plot selection over time. There is multiple inspector, the properties inspector and the information property. The properties inspector lets you change some parameters. So parameters about the filter, but also the view and the representation. And in the information, you will not change property, but you will recover information. For example, number of points, number of cells, this kind of thing. So as I said, the properties panel contains properties about the source, but also the view and the active source in the active view. So there is a concept of active source, I already explained before, but there is also a concept of active view. As we can see here in the views area, we can see one of the view is also highlighted in blue. That means that this view is also active. So here you have the properties of the active view, and here you have the properties of the active source being shown in the active view, representation property. Okay, so we've gone over the main part of the interface. But then how do we actually put some data into ParaView? So you have two ways to put data into ParaView, through the file menu or the source menu. Then how do you process the data? You use filter from the filters menu. In terms of customization, you will find edits. In the edit menu, there is many things, but one of the most important one is edit settings, where you will be able to change the behavior of ParaView. When you change the settings, they are saved into your config files in your user space. And the next time you open ParaView, they will be conserved. You will also find lots of interesting things in tools where you'll be able to load plugins, different shortcuts, different links between views, the kind of thing. How do you get help? Well, in the help menu, you have many things. You have the getting started, you have a link to example visualization, you have a link to the website docs.paraview.org. So that's the online app. There is also the offline app that looks like that, where you have information about each of the filters. Yeah. Okay, so let's try to review what we learned. There is a concept of active source or active filter. That's the same idea. There's a concept of active view. When you have both, you have the concept of active representation, which is the active source being shown in the active view. When you modify something, you have to press apply. The apply button is very important. Is this one here? So when you modify something, it will the apply button will become highlighted. Until you press it, nothing will happen, because ParaView is very lazy and it doesn't do anything unless you force it to do something. That's why you need to press apply. And the same idea, when you open a file, you need until you press apply, nothing will happen. In your pipeline, here you can display anything. Here we are showing the plot selection over time, but actually we could show any of this filter here. And when you create filters, you will see that later, but only applicable filter will be available. So we'll test that later. Okay, so let's try something. How do we create a source? So what's a source? A source is a procedurally generated data. So it's not actual data being read from this. It's just we create a sphere, or we create a cylinder, or something like that. It's just it's not usually very much used in to do science, but still that's interesting to understand how it works. So let's try. Let's take a look. I will show you how to create a sphere source and change different parameters. So here I have my ParaView open. I will close some panels that's not shown by default, like that. So this is how ParaView looks by default. Yeah, you can see it. Okay. Okay, so how do I create a source? That's quite simple. I go to sphere, a source, alphabetical, sphere source, and here a sphere, and here I find a sphere. One trick that will you will avoid losing lots of time is by using control space. Instead of going to sources, alphabetical is the same for filters. I'll go control space. It shows this small window here. Here, if I type sphere, it will suggest me the sphere. That's exactly the same as going here. that doesn't change anything, but it's much, much faster if you know what you're looking for. So please use it. You will earn a lot of time. Sorry. Left mouse click right here. Add filter. No, I'm not sure what you mean. No. Control space opens this window here. Here you can type any name of a filter, for example, clip, slice. So I created my sphere, pressing apply, and then I have my sphere created. Okay. Then doing this, I suggest to change some parameters. So I will just change theta and theta resolution. So this is different parameter used to generate the sphere. So it does change. And I will also increase the sphere resolution. No, my sphere is super resolved, but we see all the alt sphere. That's just to show you that when you change a parameter, you press apply, the change are actually committed and be computed. Of course, this is very small, it's instantaneous, but for big data sets, it makes sense to press apply only when you want to press apply. Okay, so how do we load the data set? So to load the data set, it's quite simple. You go to file, menu file, open. So if you have any question, don't hesitate to interrupt me. That was great. I will take questions at the end, of course, but if you have any question, just raise your hand. I will keep. Yes, questions? Oh, yeah. Okay, ParaView, yeah. Yeah, right here. Yeah, when I had a sphere, yeah. Oh, yeah. So you're missing as the properties. Very good point. I should have mentioned that. If you're looking, yeah. So I will explain to everyone. If you're looking for properties, but you cannot find them, just press this button here, called Advanced Properties. Just press it, and you will find the properties. It's to everywhere in ParaView. This button is present in a lot of places. So when you cannot find something, or you're looking for something, you're not sure it exists, make sure you check the advanced properties. Very good question. Thank you. Okay, so how do we load the data sets? File open. Quite simple. So let's try it. I will load the motorbike data set. So this data set is actually from OpenFOAM, of course. Okay, so here I've opened my data set. So let's try to find some information about this data set. Where do I find them? In the information panel. So can someone tell me how many cells in this data set? Quickly. Yeah. 6862212. Yeah. Okay, so that's present here. As we can see, we have also number of points. We have one time step because I need not load time step. And we also have all this data, point data, and cell data. Okay, we can see that's a multi-block data set. That's specific to OpenFOAM data, which is open as a multi-block data set. Usually that's not the case for more simple data. Okay, so right now that's some oddities about the OpenFOAM reader. And this specific data is that it's available on the disk as reconstructed and decomposed. So I can actually switch to decomposed and load my data again. And if I take a look at the information, I can see that when I load in decomposed, I actually have more time steps because that's how the data is actually. So if you're not sure what decomposed and reconstructed is, it just means that when the data was generated, it was generated on multiple core, and then it was reconstructed into the reconstructed data set. But the decomposed data is still there, and ParaView can use that to process the data with MPI and distribute it on multiple core for post-processing. But we will not see that today. It's a bit too complex. There is another parameter I want to show you. Where is ParaView? Yeah. For example, if I uncheck, where is it? create cell to point filter data. I think that's it. Yeah. If I don't check this one and press apply, I can see that now I only have cell data, no point data. So I did not explain what cell data and point data is, and that's not we're not go deep into VTK today, but you can in VTK and ParaView, you can have data associated with cells and data associated with points. It's sometimes it makes sense to use one or another. What you need to remember is that when you use cell data, you can see what is the cells. There is no interpolation. But when you use point data, there is interpolation between the points. That's one of the main difference between using point data and cell data. Okay, and one last parameter I want to show you is add dimensional units to array names. I press apply, and as I can see, now all my arrays have the units next to them, which can be useful when we want to have the units directly into the legends and this kind of thing. So this is just example of what opening an OpenFOAM data in ParaView can look like. You can change these different parameters depending on what you're trying to do. But regarding the units, doesn't mean anything for ParaView. For ParaView, the units is only part of the name. That's it. It will not be able to say, oh, you're using seconds and milliseconds, and we do the conversion for you. No, that was just the name. That's it. Okay. So we've been opening the internal mesh here. So let's try to open something different. And instead of opening the internal mesh, we'll open what's it called? The group role. Okay, so right now we've opened this. As you can see, the OpenFOAM reader lets you open parts of your datasets. And there is also the motorbike group, which looks like this. Sometimes ParaView can get a bit lost. So I just reset the camera by pressing this button. And here I can see my model, which is a motorbike. Okay, any questions so far? Yes? Yeah, it is linear. There is no way to have another interpolation for visualization, at least in ParaView. That's something that's being asked sometimes, but it's not been done. It could be done. It's not that hard. Yeah. Okay. Yes. So it's only when I open one or the other, I do have more time steps, but it's only specific to this dataset and how it was generated in OpenFOAM. I could have a decomposed dataset without time steps or with time steps. I'm not an OpenFOAM expert, so I don't really know how it works. But when I generated it in OpenFOAM, and so I generated decomposed, and then I ran the decomposed. This is the test. And I kept both of them to be able to show the open decompose and open source. That's it. Yeah, but sometimes if your dataset is only decomposed, you will not be able to open it reconstruct, and if you only reconstruct, you will not be able to open it decompose. Yes. It's a production process. It's a production process. Yeah, the production process. Yeah. Yeah, exactly. Yeah. Yeah. Yes. Well, that depends on what you do. If you want to do distributed, let me show you on Windows. That's a Windows thing, by the way. On Linux, that's not the case. If you want to do distributed ParaView with MPI, run PV servers, kind of thing, then you definitely want the MPI version. but you need to install Microsoft MPI, which is linked here. So you need to install a component from Microsoft to be able to use this. Well, you will need to set up ParaView specifically to do that. It will not do that for you. You have to run PV server with MPI and then connect to your server. So it's not automatic. You have to do it yourself. So if you don't know, you can use the non-MPI version. If you want to do that, you have to use the MPI version instead of MPI and read the documentation about how to do that. It's multi-threaded. Is it? Yeah, everything is multi-threaded. Well, everything. Not all filters are multi-threaded in ParaView, but all the main filters are multi-threaded. That's for sure. Yeah. No, you don't need to. You could use it as a test or as a demonstration, or maybe you want to test what will happen when you send it to your HPC later, or that kind of things. But other than that, it doesn't really matter. I never, when I use ParaView, not for development, not for testing, but just for doing something, I never run with PV7. I only run with MPI when my dataset is too big for a single computer, and I run on multiple nodes or multiple on HPC, this kind of thing. Yes. So yeah. So there is two OpenFOAM plugins in ParaView. There is one which is inside of ParaView, also not OpenFOAM plugins. There is one OpenFOAM ParaView, which is the one I've been using here. And there is an OpenFOAM plugin, which is available only in ParaView, which provides another OpenFOAM plugin with less capabilities than the one which is in ParaView, but supports some features that this one does not support. So what I would say, and you want to talk about, you want to talk about that with Mark Olsen, which is a OpenCFD ESI guy that actually works on this, and it will explain to you which specific use case where you want to use the one from ParaView. But for the generic use case, just the one inside of ParaView is perfectly fine. Yes. Sorry, I didn't get that. Yes. So are you talking about point data interpolation for point data? Yes, as I already answered, there is only linear interpolation for point data rendering. I'm sorry, man, I don't understand. Yes. Should you use what? Which version should you use of ParaView? 5.11.1, the last release version of ParaView. The last one. Yes. Yeah. Okay. Let's keep going. Okay. So ParaView is not only an application but also an architecture. So what do we mean by architecture? Well, first, for starters, it's open source and it's BSD license. The BSD license is a very non-restrictive license, which means that you can use ParaView and put it into commercial software or use it anywhere. The only thing is that if you provide it to someone, you need to say that it's coming from Kitware, basically. That's it. And it's cross-platform Linux, Mac OS, and Windows. It's fully controllable via Python scripting. So that's what makes it very powerful. How do you use that with Python scripting? Well, you can create a trace. Well, when you do actions in the interface, you can trace what you do, and it will generate a Python script, which contain all the Python methods you need to call to do the same thing you've been done in the interface, but to do that automatically in Python. Then you can run this scripts in PVPython or in PVBatch. We'll see that later. It's also extensible because you can write your own Python-based algorithm. You can then load them as Python plugins and change the interface. You can even create your own C++ plugin, and you can create ParaView-based applications, which are full conversion of ParaView into a custom application, but still with a similar interface, but with different logos and kind of thing. Basically, yes. Well, the Python shell is more like for trying things. You can run a script in the Python shell if you want, but it's just like using a macro that will do something for you. But when you use PVPython, you basically say, okay, I've written my script, but we have an example after that. But when you use PVPython, you say, okay, I've written my script, and then I run PVPython, it will create some screenshots. Then I have my screenshots, I can share them or put them into my article or do screenshots or animation or data, just the output of my post-processing process. And PVBatch is similar to PVPython, but PVPython is an interactive Python interpreter. It's non-interactive. You can run it without a script. You have to run it with a script, but it supports API. So you can run PVBatch with API. And basically do the things, the same thing you were doing in Python, but on multiple cores, basically. Python does not support API. It does support API. Well, you can. To run Python shell, you have to run ParaView first, then click somewhere, and run the script. But with PVPython, yeah, well, PVPython is just a shortcut to be able to automatize your workflow, basically. And also, with there's a small difference with the Python shell is the Python shell is not responsible to triggering the interaction because there is a Qt interface. There is only interface with it. So there's a small difference between Python and Python shell, but it's going to get technically fine going to it. Okay, so yeah, we will not cover Python scripting more today. We'll talk more about it the second workshop in advanced workshop. So if you want to learn about Python scripting, I will talk about it more later. Okay, so it's about display. Yeah, indeed, in ParaView, there is many different ways to display data, many different kind of representation, point representation, surface with edges, volume rendering, interactive lookup table that you can change, so you can change the color and the opacity. You can show multiple things at the same time using the pretty window, and you can add some annotations. How do you control the visibility of the different items by clicking on the eye? It's on the pipeline browser, and this is how you control what is visible or not. If the eye is not available, like here, it means the data is not displayable in the current view. For example, why is that? For example, here, it's a plot, so it's a 1D data, and you cannot show it in a 3D view. You have to switch to, for example, the chart view to be able to show it. In any case, sometimes this is a very classic error that people can do. Where is my motorbike? Right here. Is that people will open the data, and instead of pressing apply, they will press the I. You don't want to do that. I will not go into the technicality because it actually works. As you can see, I can do it. But until you press apply, the software is not behaving as you would expect. So it actually makes sense the way it behaves, but it's very confusing. And we should not let you do that, but yeah, sometimes there is bugs. So please do not do that. How do you display the data? Well, you change, you choose, first you have to choose a representation. Okay, so here I have this volumic cube. I'm currently using surface, but I could switch to points or to surface with edges. Here we can really see the multi-resolution mesh of the OpenFOAM data, or even to volume if my GPU is happy. Oh, I didn't run with GPU, or did I? Okay. It's I'm not running with GPUs right now, that's why it's very slow, but that's the volume of presentation. Yeah. Let's go back to surface. Now to control all that, you can change the color. For example, here I have the surface. If here I will control if I display the color legend or not. And here I can change all the color map information. So for example, I can change the different value of the color or select a different default, a different preset, sorry. Like that. I can rescale. So here I have the rescale to data range, but if I want, I can rescale to any specific range I want. For example, I will rescale from 0 to. Okay, so now it's very dark because that's not a great value. I can also change the variable I want to map. So here I'm using P, but I could use omega, K, or anything like that. And I can change the components. This one is a vector. So for scalars, of course, there is no components, but for vectors, I can change magnitude X, Y, Z. For tensors, I would add also tensor values. So yeah, as you can see, whenever we want to show scalars, we're using lookup table. So this is very essential in ParaView. There is many parameters in the lookup table panel. But what I would suggest you to do when starting is to use indeed the presets. So here you have a subset of the presets, so that's not that many. But if you go to here, this button, you have many more presets. So you can take a look if you want to find the preset that is correct for your data. But then, if you want to change something, you can change anything you want. You can use any color you want. You can even change interactively, but it can be hard to do sometimes. But it's important. For example, I can change that interactively. Okay, let's try to do something with a motorbike. Okay, so I will open the motorbike and I will change the different type of representation, change the surface color, the edge color, and use representation scaling. Okay, so yeah, my motorbike, but I will open only the model. Okay, I will reset to see the model. Okay, I change the color, surface color to something like that. And I will change the edge color. So I'm using surface with edges, and I can change, for example, the edge color. So this is just to show you that you can do it, and there is many other parameters. So let's use yellow. Okay. And then scale the motorbike too. Indeed, there is this transform on the representation panel. So here I'm using the touch. This is very useful when you know the properties you're looking for, but there is many properties. So sometimes it's more easy to just look for it. And I will scale in Y by 2, like that. Okay, I have a big motorbike now. Just to show you what you can do. Okay, so view is a window that shows data. So I'll show you the different type of representation, but there is also different type of view. So we've been using since the beginning of the course, we've been using the render view. But there is also line chart view, bar chart view, plot matrix view, many type of view. There is even a Python view where you can write your matplotlib script if you want. Some filters will automatically open a specific kind of view. For example, if you use an histogram filter, it will open automatically the bar chart view. So here we have a render view. Here we have a quartile chart view, which is a specific type of view. And here is a spreadsheet view where you can see the actual values. The view properties are available as well as, and depending on the view, selected view, you will see different properties. Of course, for the chart view, you will have title, axis information, this kind of thing. For the render view, you will have properties about the render. And how do you create multiple view in the same? You have to use a multi-view. So by pressing on this button here, which is available here, you can create multiple view in the same layout. You can move them around, you can detail them, you can put them full screen, and you can link cameras. So don't forget the active view. This is very important. Sometimes you will not find the properties you're looking for because you forgot about the active view. Okay, so I will show you a little bit how to play around with the views. Okay, so I will only load some parts of the motorbike and try to compare them with multiple view. Okay, so I will just create a new view. I have my motorbike here, but I will only load some parts. So as you can see, I've been loading some groups, but let's try to load some patches instead. So I will open the front rear only, like that. Okay, I have this part of the motorbike. I will open it again, but this time I will open another part. Which parts does it suggest? Yeah. Yeah, this part. So there is no group for the specific part specific patch I want to use, so I have to select them manually. Okay. Okay, now I have opened the motorbike 2 times, and at some point I open a certain patch for the other one. I open another patch. So now I will also split the view in 2 by pressing this button, and split it again by pressing this, and then I will show this and this. So now I'm showing the motorbike, different parts of the motorbike like this. And let's say I want to link the camera together because I want to be able to do some visual comparison. I will go right-click, link camera, and click here. Right-click, link camera, and click here. And now I will be able to do something like that. Let's use the camera like that. Yes. So you can do some kind of visual comparison. And you can even do this kind of thing, change the representation of one. Yes? Yes. Absolutely. That's even simpler. For example, here I will just open my motorbike here, but I will open the whole. Why is it? Okay. Why can't I find the? Okay, so I just open the motorbike again. Let's say I want to compare one value and another value, which like that. You can just do like that. And there you go. This is what you wanted to do, right? Oh yeah. Yeah, that's the same thing. You can just do the same thing. That's it. Yeah. Yeah, go ahead. Yes. Yes. Oh, by using some kind of regular expression, for example. How do you want to select them? If you're not selecting them manually, how do you want to select them? Yeah. Oh, based on the name. I'm afraid not. There is this extract block filter that do something what you want, but you still have to. Yeah, you can do that using selectors. This is the manual selection here, and here is the selectors where you can actually put some using a specific syntax, which sadly I do not know myself because I never use that. But using selectors, you are able to select groups based on the names. So I think that works for you. You have to, but you have to check it for yourself. Yes. Sorry, say again. Yes. You want me to show again? Okay, sure. So how did I do that? So I just open my motorbike and it shows like this. So I press this button here to split the view in two. And here I select point of view. And here I show the motorbike by pressing on the eye. And now it's like that, but it's not linked. It's the same variable. So we change the variable on the second one. Okay. And then I will right click on one view, link camera, and I click on the other view. And right now they are linked cameras. Okay. Okay, that's it. Okay, so ParaView is of course for analysis. There is many filters in ParaView that are provided to you to be able, so you can analyze the data. So you can do processing on the different variables from point data and cell data. You can change the parameters very easily of each the filter. You just change them. You can select data. For example, you can see here some data has been selected using the custom. You can show the data into charts and 2D views. So the idea of using the filter is only to extract the data you're looking for. How do you find filters? In the filters menu or by using control space, as I talked about before. Control space or alt space on macOS will let you write the name of the filter you're looking for. There is also the command toolbar filter, the command filter toolbar, sorry, where you find all these filters here, which are basically the filters that are being used 99% of the time. So usually you don't even need to go to filters, you can just click on the toolbar. When you create a filter, it's connected to the output of the previously active source. So for example, on the motorbike, if I created a filter on the motorbike, it will connect automatically on the motorbike. And then if I create another filter, it will connect on the previous filter, and so on and so on. If I change the active source, of course, it will shortcut. Some filters are available or not, depending on the current active source and the current state of the application. Some filters will change the type of the data. We have not talked at all about data type and how it's handled in VTK, but what you can keep in mind is there is structured data and unstructured data. Unstructured data is more flexible, but way more costly in terms of memory and computing power. So yes, when you create a filter, you can change all the properties, then you have to press apply. Until you press apply, nothing happens. You can reset for pressing apply if you want to reset the changes. And you can also press delete to delete the filter. And there is a help button that shows the help for the specific filter. There is undo redo. You can undo and redo a change that anything you've done in the application. You can even camera undo, camera redo for the change of camera orientation. So if you make a mistake and you have not pressed apply yet, you can press reset. But if you've already pressed apply, you have to hit undo. Okay, so let's talk a bit about some filters. Clipping. So clipping is a very common operation, especially when you're working with a very big domain. Some part of the domain is really not interesting. There is nothing to extract as data. The clipping will always generate an unstructured grid, even if your input is a structured grid. Why is that? Because, sorry about that. Because the clipping may cut through the cells. Even if they are structured cells, the output will be unstructured cells. Okay, so let's try it with a motorbike. Okay, so I have, I will reopen it from scratch. Why is it not here? Oh, it's right here. Okay, so here I have my whole domain. Let's switch back to default projects. Okay. Here I have my whole domain, and of course, the data is more close to the motorbike. So we'll flip into the domain to be closer to the data. But one thing you may need to do with OpenFOAM data is that you may need to check this decomposed polyhedra. By default, it's checked, but make sure it is, because sometimes the data set is a bit strange and ParaView do not expect what it gets. So make sure it's checked. Okay, so I press clip here to create a clip. Okay. I will try to isolate what's interesting in the data. So as you can see, the motorbike is right here. So I will just put it here because we don't want everything. And I will create another clip because we don't care about what's above the motorbike. So I create another clip. And here I will change the normal with the Z normal. Okay, that's good. Okay. Here I have a much more smaller domain, which I should be able to work with. Okay. And can I see anything here? Not really yet, but we're closer to the data. So we will see how it goes. So slice is a very similar operation as clipping. Just create a slice into your data set. So the slice is basically a 2D plane that will extract the data from the data set. When you create a slice, the same way as a clip, there will be a widget that will help you position the slice. Okay, so let's try it. I will press the slice button, which is this one, slice. As you can see here, it's increasing my pipeline. So it's not random operation. You can go back, you can change the parameter of a previous clip to increase the size of the domain. You can change anything. Nothing is unchangeable. So here, of course, I may want to slice through the motorbike. This is probably where the most interesting information is. So I will, no, not this one. Yeah, why normal? As we can see, we are exactly through the motorbike. So we just press apply. And I will hide the plane to see something. And here we can see our motorbike. Let's take a look at the different variables we've been able to extract. So here we are clearly able to see some data and extract some information. Okay. Yes. Yes. You have a filter which is called descriptive statistics, which will compute statistic value on a full data set and all the variables on it. For example, let me try it. Descriptive statistics. As you can see, let me select the variable of interest. And when I press apply, all these values are being computed. So I have the maximum, minimum, mean, standard deviation. Okay, so that's basically the way to do it. If what you want to do is actually computed by this filter. If you want to do more complex operations, you have to go with a calculator or Python calculator where you implement your own stuff. Yes. Yeah. Say that again. Yeah. Yeah. Yes. Really, the order on the pipeline browser matters a lot. This is basically here, for example, my descriptive statistic filter I just created is only run on the result of the slice. If I run it on the clip, I will have completely different results. Sorry? Oh, definitely. That's why you want to clip your domain. If there is no interesting information on the edge, just clip it. Yes? It's not to say seeing your data. I understand kind of what you mean, but I think it's specific to your data. So I would have to see your data, but we can definitely do that after the workshop. You can show me things, that's fine. Okay, yes. Absolutely. There's many features that actually calculator, Python calculator, or even Python calculator. As a whole, we cover as a general discussion. Yes. Yes, absolutely. If you look here, here you can see automatic rescale range mode. It's go and update on apply, but if we switch to never, it will never change. So if you set it, and even when you set it to a custom, oops, sorry, when you use a custom range, because you know exactly what you want, as you can see, the main button is rescale and disable automatic rescaling, because we understand that people want to keep their range specifically. Yes, that's what I'm talking about. That's colors. Yeah, the range of the color map. Yeah. Sorry, two people talking at the same time. Go ahead, finish your question. Yeah. Yeah, absolutely. Yeah. Oh, got it. I got it. So what you can do, there is a few different ways to do that. So firstly, there is a categorical setup, but it's only work when you have like less than 20 values. Well, you will really pick one for one value, one color, one value, one color. But if you have 1,000, it's just not possible to do it like that. So yeah, here I could do something like that. But it would struggle, I think, to even I have way too many. So I think I crashed it. But another way to do that is to use the number of sorry. Let me show you. Let's take a slice so we can actually see something. Okay, and switch to something. Okay. Okay. So you can reduce the where is it? You can reduce the color discretization. Currently, it's 256, but if I say 30, for example, I can see that it starts to look like that. So that's one way to do it. The problem with that is sometimes you may want also to have labels for each of the colors, which this will not let you do. So that's a trade-off. With the categorical, you will have one label by color, but you have to do the color yourself. With this, you don't have the nice labeling, so that's a trade-off. That's a feature that people have been asking for, to be able to have two at the same time, but it's not done yet. Okay, yeah, we may need to go a bit faster because it's already 30. Too many questions. So I will just keep showing you things, but we just skim over exercise so we can end basically in time. Okay, so another feature which is quite interesting is a special game. Lets you select cells by data values. So the result is an unstructured grid, and you can select between two values or all values higher than something, all values lower than something. So that's how it looks. You can also do contour, or let me show you a contour at least. Okay, so here I have my mesh, and I can do a contour on it by pressing the contour button, and something like that. There's nothing because I need to switch to mesh, I think. Yeah. So using contour, you can generate surface, which are as a contour, basically. which can be super useful in safety. You can also do extract block. This is something I showed just before, where your data set, especially in the context of OpenFOAM data, as the data is always a multi-block data set. So, for example, if I open the motorbike, the motorbike group, and like that, and here, if I add an extract block filter, as you can see, I can extract the part of the data set that interests me. And then I can use group dataset to put them back together. And all of that can be controlled in the multi-block inspector. The multi-block inspector looks like that. If you go to view, multi-block inspector, it's right here. And yeah, I need to select. So here you can see that I'm actually showing everything, but I can actually select any of the blocks from the data. And I can decide to hide it or even change the color. So you can do a lot of things with the multi-block inspector when your data is a multi-block. And then you can also merge block, because group data set create a multi-block, but merge block will take a multi-block data set and put it into an uncertain way or total data. So you will lose all the block information, but you will have a data set that contains everything. There is also the connectivity filter that will let ParaView compute if some part of the data set is connected or not. And finally, I think that and we also have the stream tracer. Of course, stream tracer is very important when we do CFD. What is a stream tracer? Basically, you generate streamlines in a vector feed from your feeds. So the input can be any type of volumic data set with a vector on it, and then you put feeds into it that will create all the streamlines. Of course, the streamline will end when they reach natural boundary or something like that. So let me show you quickly how it looks. Here I can add a stream tracer. For the testing. So here I create my stream tracer. I select point cloud to be able to position a sphere that will contain the stream, the seed, and we'll just put that in front of the motorbike. Let's get that, yes, and here I have my strings that are being generated. And then on top of that, you can create glyphs with arrows and everything. And you can create also plot over lines, which will let you position a line in the volumic data set and plot the data on the line. Then you can save your data. You have all your results. You can save it as a new data set. For example, a CSV file, a BTK file, a BTP file, or GLTF file, any file you want, any file format you want. You can also, of course, save screenshots. You go file save screenshot to save resolution. You can even go higher than your screen resolution. And you can say state that will basically save the state of the application, so you can reload the state, and ParaView will be exactly as it was when you close ParaView. You have bar chart and line chart view, and we talked about that. You have the spreadsheet view where you can show the point data and the cell data. And to finish, as I said, ParaView is made for massive scientific datasets. It uses a client-server architecture, so we have not talked a lot about that today. We talked a bit more this afternoon. It runs on the Viper platform from netbooks to HPC. So yeah, it's made for scalability with this kind of client-server architecture. So if you want to go further, you may want to take a look at the ParaView user guide. It's docs.parv.org. Very comprehensive. There is lots and lots of content. So take a look at that. There is even tutorials that contain what I've shown today, but in a much more extended form. And there is a discourse where you can ask questions. If you ask questions, people will answer you, maybe myself. Yeah. And to finish, in September 19, there is a ParaView user day in Lyon, France, where Kitware Europe headquarters are. So if you have not registered yet, you may want to go there if you want to meet other ParaView users and hear some inspiring keynotes and even meet with the ParaView programmers. That's it for me. Thanks, everyone. Yes. Okay. Yeah. 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 Yeah, sure. Yeah. Oh. Yeah, but in your case, you cannot use a film filter. You have to use a specific filter that will convert particle to streamlines. It's called particle temporal particles to pass line. That's this one. No, that's this one. The one you want is this one specifically. Temporal particles to pass line. Yeah. That will you will see the lines appear as you play the time steps. Yeah, yeah, exactly. Yeah, exactly. That's what you want. Okay. Any other questions? Yes. Yeah, behind. Yeah, sorry. Sorry, say again. Okay. What was the first word you used? Eulalia? I don't think there is anything related to Eulalia method in ParaView, so I'm a bit confused on what's consists of. You will have to send me the article or something. Sorry, but let's talk about that later. Yes? In a way, the sphere is a mathematical function. The sphere source I've shown before. The sphere. It is. There is an origin point, a radius. Okay. But then maybe you want to define your own mathematical function to be able to use that and create some data. You can do that with a programmable source. In a programmable source. Yeah, in a programmable source, you can write any Python code, and you can even use NumPy or something like that to do whatever you want. Any other questions? Looks like that's it. Thanks everyone. Thanks again. And come to ParaView then.